Abigail, it's Miss Snook. I'm going to show you how to balance the equation. The first one you gave me, H2SO4 plus 3KOH goes to K2SO4 plus 2H2O. And I have parentheses here to show you that these particular things are polyatomic ions and they stay together. So when you're balancing your equation, you keep those together as a unit and you look at them as one thing. So over here with water, instead of writing it as H2O, I wrote it as HOH, which is the same exact thing, so that you could see how the OH from over here transferred over here. The next thing you do is you make a T-chart, and on one side you put what's going into the equation, which are your reactants, and what's coming out of your equation, which are your products. So I've written them in order as they are on the reactant side to keep them straight. So we have hydrogen, you have two atoms of it. You have one SO4, you have 3 Ks, and you have 3 OHs because this 3 right here multiplies across the entire molecule. The subscripts are only for the atom that it is written next to. So that's why I know there are 2 H's. 2 H's. On the product side, we have 2 H's as well because we have a coefficient of 2 here that multiplies all the way across. And I already see a mistake that I made. This should be 2 down here. All right. Then SO4, you have 1. Ks, you have 2. And OHs, you have 2 because this 2 multiplies across. So when you look at your T-chart, you see that your hydrogens are the same on both sides, your SO4s are the same on both sides, but your potassiums and your OHs are different. And so what you need to think about is a number that is a common multiple of 3 and 2 that can help you balance this equation. So the easiest way to find out what the common multiple is to multiply 3 times 2, so it will be 6. And you need to adjust your coefficients accordingly so that they match on both sides. So in order to do that, you just cross out, let me get a different pen, your coefficient here, make it a 6, and cross out your coefficient here, make that a 6, and let's see what that does to the equation now. So on the left side, we didn't mess with the hydrogens or the sulfates, so that stays the same. And oops, I forgot to add in a 3 here because we got to deal with the K2. All right, for the Ks, we changed this to a 6. So if we go down here, we cross that out, it becomes a 6. And it also affects the OHs because the 6 is a coefficient, so it multiplies across, so we have to change the OHs to 6. On the right side, H has been affected. It is now 6. And SO4 has been affected. It is now 3. And K has been affected. It is now 6. 3 times 2 is 6. And OH has been affected because of this 6 right here multiplying across. So now when we look at our T-chart, we see that we are balanced down here, but we're not balanced up here. So our H's and our SO4s are unbalanced. So we need to look and see what we could do to change that. So if you look at the side that has the most on it and look at what you would have to do to the left, the other side to get it to these numbers, and we're talking about multiplication here, you can see that in order to get SO4 to be 3, we would have to multiply that by a 3. And in order to get H to be a 6, we would have to multiply that 2 by a 3 as well. Now that 3 just goes right out in front of your H2SO4 on the left-hand side. And that's going to change your numbers again. So let me get another color. And so 3 times 2 on the H's becomes 6. And 3 times the 1 SO4 that you have here becomes 3. And now when you look at your T-chart, you're balanced on both sides. So the new equation, the balanced equation, let me copy this and move it to a new page so we can look at it, is going to be 3H2 SO4 plus 6K OH goes to 3K2 SO4 plus 6HOH. And if you want to, in that final equation, to write water like water, that's fine. You can write it as 6H2O. So I hope that helps. Let me know if you need more help. Bye.